That's the equation. Connecting volume with the radius. So that is step 2, to determine the equation or relation or equation connecting or relating these two quantities, volume and radius. Okay, what's next? The next step is actually pretty interesting, and we already used this step before, so step 3 will be, we used this step in many situations already. We used it in implicit differentiation, now we'll use it again. So step 3 is this, left hand side derivative equals right hand side derivative. I mean this equation, in this equation left hand side is just V, volume, right hand side is this formula, and now we need to calculate both derivatives. So left hand side, once again, left hand side is just volume, and volume is a function, it's a function of time because it changes with time. So the left hand side derivative is the volume derivative. These are my notations, left hand side derivative, right hand side derivative. Now the right hand side is 4/3 pi r cubed, and this r here is a function. You can think of it, it's another function. So v is one function, r is another function. Like you can think of it as r of t, but I will not write t in parentheses, but I will always remember that this r is actually a function. Radius changes with time as well. And having this in mind, how do we calculate the derivative of that? It's like same as y in the problems about implicit differentiation. So when we calculate derivative involving this, we calculate the derivative normal way, but then we multiply times y prime. In this case, we multiply times r prime. If it was y, we will multiply times y prime, or whatever this letter is, multiply times that letter prime. So derivative of this will be what? 4/3 pi is just numerical multiple, so we keep it, times. Now derivative of r cubed is 3r squared. And like I said, we've got to multiply it times r prime. Of course we can cancel the 3, and we will end up 4 pi r squared r prime. This is the derivative of the right hand side. And now left hand side derivative equals right hand side derivative, therefore what we get is v prime equals 4 pi r squared r prime. So starting with this equation that we found in step 2, this equation actually relates the two quantities, only these two quantities and some constants. But then we obtained a new equation that involves not just these two quantities but also their rates or derivatives. So the result of step 3 is a new equation that relates not only the original quantities but their derivatives. So v prime and r prime. And also it may or may not involve the initial quantities, like this one involves r but it does not involve v. Okay, and now this last equation will be the tool that we will use to calculate what we need to calculate. So remember that what we need is, so we try to plug into this equation whatever we know and calculate whatever we don't know. So remember that what we don't know is r prime, so this is the unknown. This is what the problem was asking to find. Now, we do know v prime, and remember v prime is 5. In fact, it's 5 cubic feet per minute. Now 4 is just a number, pi is just a number, r squared, again, radius is given, radius is 10, therefore it's 10 squared. And by the way, the units are, since radius, or yeah, you can put it like this, 10 feet squared. So we apply to units the same operations that we apply to numbers, like if we square the numbers, so we square the unit as well. Anyway, so what we got is this 5 equals 4 times pi times 10 squared and times r prime. And now it's easy to calculate r prime, we just need to divide everything by this 4 times pi times 10 squared. So r prime equals 5 divided 4 times pi times 10 squared. And now we can, if you wish, you can cancel. So 10 squared is 100, and cancels with 5, or otherwise you can just calculate this on the calculator. So let me just calculate this on the calculator.
Ну ничего, я сам.
So 5 over. Remember, when you use calculator, then the denominator should be in parentheses. 5 times 100. So what I got is a pretty small number, approximately equals 0.004. So that's the answer then. This is the rate of change of radius. So the radius changes pretty slowly, and so hopefully the ball will not burst. Now the last question is, what are the units? I mean, 0.0044 thousandths of what? And in engineering, units are pretty important, so how can we find the units? One way to find the unit is just by common sense. Like, what was this r prime? It was rate of change of radius, how fast the radius changes. And since the radius is measured in feet, and the time in this problem is measured in minute, because the rate of change of volume was cubic feet per minute, so it should be feet per minute. So that's just kind of common sense way to calculate, to figure out the unit. Now, if you don't like this common sense, then you can actually do it in more precise way, like they do in physics. Just figure out the unit of every part in this formula and see what the unit of the result is. Like the unit of 5 is the rate of change of volume, and the unit of 5 is cubic feet per minute, so it's a feet cube per minute. Now this 4 comes from this 4, and it doesn't have a unit. Pi doesn't have a unit either. 10 squared is the radius squared. The radius is measured in feet, therefore 10 squared measured in feet squared. And now we can cancel the units in exactly the same way as we cancel numbers. Like this feet squared cancels with this feet cube, and now we only end up with feet, and then the mean stays there, so that's why it's feet per minute. So the rate of change of radius, like how fast the radius changes at that moment, it's like 4 thousandths of a foot per minute, which is pretty slow rate.